Hello everyone, this is Paige Stichler and this is the Agarwal Automobiles case study. So I'm going to talk about the Kenneth Kahn framework, and then I'm going to go over all the different forecast calculations that I performed, and then I'll discuss how I arrived at the optimal solution, and then also talk about some of the qualitative factors to consider as well when forecasting. So first is the Kenneth Kahn framework. It's broken down kind of into 4 different segments, whether the product has existing history or not, and then whether the market has existing history or not, and then that kind of gives you a recommendation on how to approach your forecasting. So for Agarwal automobiles, diesel and petrol and all that, that's an existing product. It has existing history. So you can look at the past data and, forecast from there. So that would fall into the market penetration box. So that's where you can use a time series or regression model to do your forecasting. Then you've got, a new product that has no history but there's an existing market. So then that'd be fall into product development, and then you can do like a regression of a looks like product. So um, you can find something that's similar and try and base your forecast on how that product performs. These two would take quantitative methods to forecast, and then these bottom two, market development, that's an existing product but a new market. So if you want to try and take your product, maybe that you sell in the United States, and you want to try and sell it in India, for example, you're going to have to do a lot of customer research and sort of that sort of thing to figure out how your product is going to do there, because how it performs in one market is not how it may perform in another market, but the product is still the same. And then lastly is diversification. So that's a new product and new history. So that's just launching a whole new product with really nothing to go off of from previous experience, previous data. So these two would take you would need to use some qualitative methods to try and do your forecasting, because there's not going to be previous numbers or data to base that off of. And as far as like a company that I think should or could use a different strategy, the last company I worked for, Bendix, they make brakes for commercial vehicles, for semi trucks, and they have years and years of history. It's a pretty stable product, so they kind of, and it's cyclical with that industry, but they have so much data to go off of that they kind of know what to expect each year. But they're now launching new products for electric vehicles. So these products, they don't have that previous data to go off of because it's new, as they're trying to bring this new technology to semi trucks that's already exists in cars. Like the alerts that if you're going out of your lane, or the alerts that kind of apply your brakes if you're not braking in time, that sort of thing. So that would kind of fall into product development almost, because there is an existing market for people that purchase electric vehicles but not for semi trucks. So but it is a new product for semi trucks, or even market development, because electric vehicles, there it has existing history, but it's a new market for selling it to semi truck drivers, instead of selling it to normal consumers for their cars. So I think that the market penetration model works for them currently with their current product, but going forward, they're going to have to switch to, one of these other two products, or even maybe diversification. It is so new in a new market that they're really just going to have to try different methods to forecast, because it's not going to be like anything else they sell. So for the Agarwal automobile case, the first method that I used to forecast was the moving average, and this is basically just taking an average over a period of time. It can be days, months, years, and it can change. So right now, for this formula, I have it set for 3 days, but you can change that number and it'll update these columns below. And so maybe you want to just look at what did I do for the past 3 days, or maybe you want to look at what you did for the past 30 days and kind of average it. And that gives you the flexibility to do that. And after I did that for all these different periods using a data table, the lowest MAPE for petrol was with 8 periods or 8 days of data. For diesel was 18 days of data, and for HSP was for 1 day of data. So it did vary for each one. The second one I did was exponential smoothing. So this is like a weighted moving average, and you can use alpha to give different weights to different values in the past, and it can fluctuate from nearer to further dates. So if you want to give more weight to more recent days, so if you're looking at the past 10 days and you want, the past 2 days is more important to you than the past 8 days, you can give it a higher alpha so it puts more emphasis on, the past 2 days instead. Or if you want to weight all of them equally, you can give a really low alpha, like 0.05, and that'll just look at all 10 past days and weight them evenly. So after I did that, I also did another data table, and an alpha of 0.25 gave me the lowest MAPE for petrol. 0.15 alpha gave me the lowest MAPE for diesel, and 0.75 alpha gave me the lowest MAPE for HSP. And so then the next method I used was Holt's method, which is double exponential smoothing. So that's similar to exponential smoothing with the alpha, but then you also have the beta that can account for trends. So, some trends to consider for the petrol, diesel market is, as more electric vehicles come into the market, how is that going to affect your sales overall? Is, the purchase of gasoline going to start to go down as more people start buying electric vehicles, or as if it becomes more mandated? So after I got the formula set, then I use solver to tell me what alpha and beta would give me the lowest MAPE for petrol, diesel, and HSP individually. And so these were the values that would have given me the lowest MAPE for each one, and they all varied again, of course. And then the last method I used was the triple exponential smoothing. So for this scenario, we were looking at months instead of days, and it's looking for any instances with seasonality. So in my formula, I left it at just 1, so that's going to let Excel kind of look and see if there's any seasonality on its own. But you can plug in different numbers in different things if you know of seasonality. But by leaving it as 1, it looks for it itself. And so after I plugged in the formula and did all of that, then I did the forecast sheets, which is another option that you have in Excel that it can do. And after I did the forecast sheet, I found it interesting because it's not so straightforward when you're just looking at all the numbers and all the columns. But once it forecasts for you, that's where you can really start to see some trends appearing that you wouldn't have noticed otherwise. So for petrol, this blue line is just our values that we already have, and this green line is what it's forecasting. So I wouldn't have noticed it before, but this, based on this model, it's expecting petrol to increase over time, the demand. And then for diesel, it looks like it's forecasting it to decrease a little bit, but it's still thinking it's going to do that up and down pattern that it seems to have. So it does seem like diesel has a little more seasonality, or some cyclical variation in there. And then for HSP, that another one I didn't notice is like it's estimating that it's going to go down over time. So, even though our values were clearly going down, again, it wasn't so obvious just looking at the numbers in the spreadsheet, but once it puts it in the graph, that's when you can see, it, for whatever reason, it's expecting HSP to go down. So after I ran all of the different models and got all these different MAPEs, the lowest mate for petrol was with double exponential smoothing at these values 0.219 and 0.003 for the alpha and the beta, and then the lowest mate for diesel was with a 20-day moving average, and then the lowest mate for HSP was with exponential smoothing at 0.75. So if I had an employee or employees that were willing to do 3 different methods, I would probably go with the 3 that are highlighted blue because that's going to most likely be the most accurate to what you really need. But a lot of companies, they don't want to have to teach and learn 3 different methods or, run their business that way. So if you want to just pick one overall, um, you can average these all across or add them all across and say, like, what's your lowest overall error? And that was actually the lowest mate for HSP was actually the lowest total combined error. So if I were only going to have one method performed to do my forecasting, I would probably do the exponential smoothing at an alpha of 0.75, because if you chose this double exponential smoothing, yeah, it's the lowest for your petrol, but it's like almost the highest for your diesel and HSP. So you would be really close on your higher volume product, but you would be so far off on the other two that the error would really wipe out any savings you'd have with your petrol by forecasting close. The 20-day moving average, the other numbers aren't too bad, but they were just better with this one overall. So that would be my recommendation, to just do exponential smoothing at 0.75 for all 3 so that you have one method, no less confusion and all that. So that's all based on some quantitative factors. So with forecasting, there's always qualitative factors to consider. So those are things that are not just based on the numbers and the data. Some things that you'd have to be able to predict or account for that could fluctuate your demand from the norm. So um, for the petrol, diesel, HSP industry, one thing that could affect your business is customer satisfaction. You, even if your demand isn't changing, if you have, several instances where you just are giving very poor customer service, you're going to start having customers and consumers want to go elsewhere. So maybe your demand hasn't changed for gas, like the petrol, the overall amount is still needed, but people don't want to go to your businesses because you're not giving good customer service. So, watching your reviews or that sort of thing. And now with social media, like, you can have one bad day or one thing go wrong or say one thing in the media wrong, and then next thing you know, you're losing all of this business. And so that's a qualitative, that's something hard to predict, but it could impact your sales and your forecast. And then another thing is new product introduction. So with the gas industry, as electric vehicles come into the market, that's going to have an impact on your sales and your demand overall. So you can't always look at your past data and say that you're going to continue to follow that pattern. As new things come into the market, that could change your average each year. And then another one would be some new policies and regulations, especially with environmental policies and pollution and that sort of thing. They could change some regulations on the product that you're producing and selling, and that could have an impact on your demand. It could make it more scarce. It could, become illegal one day. The whatever your product you're selling, it may not meet certain requirements. But also, just the politics and that sort of thing, where you're sourcing that from, if there's any turmoil or anything like that there, it's going to be hard to get your product, and it could become more scarce that way. Or they could change, it wouldn't happen overnight, but they could change things. One day they could say no more vehicles could run on gasoline, that sort of thing. So as these new policies and regulations come out, it's definitely something to pay attention to, because it could affect your demand and your forecast. And that's it. Thank you.